Students, come to next one, that is population. Population. Here the population is defined as total number of individuals. Total number of individuals of a species. Total number of individuals of a species in a geographical area. Total number of individuals of species in a geographical area which can interbreed to produce fertile young ones, that is called population. In general, total number of individuals of a population in a given area, in a given geographical area, that is called as population. Total number of individuals of species in a given geographical area, that is called population. The population shows the special characters. The characters of population. The major characteristics of population shows. One is population density. Population density. Birth rate. Death rate, and one more, sex ratio. These are the characters of population. Population density, birth rate, death rate, and sex ratio. Here, population density means number of individuals. Of a species per unit area, that is called as population density. The number of individuals of species per unit area, that is called as population density. If the population density is always equal to the number of individuals in unit area divided by number of unit areas. The number of individuals in unit area divided by number of unit areas. Here the number of individuals in unit area, that is denoted as n. The number of unit areas, that is S. Here the PD equals population density is always equals to n by S. The number of individuals of a species per unit area, that is called as population density. And one more character, birth rate. Birth rate is also called as natality. Birth rate is also called natality. Here the natality or birth rate means number of births in a population at given period of time. Number of births in a population at a given period of time, that is called as natality or birth rate. Number of births in a population at a given period of time is called as birth rate or it is called natality. Next one, death rate. Here the death rate is also called mortality. Here the mortality means death. Mortality or death rate. Here the death rate or mortality means number of deaths in a population at a given period period of time. The number of deaths in a population at a given period of time, that is called as death rate or mortality. And number 6, ratio. The ratio of male and females in a population. The ratio between males and females in a population, that is called as 6 ratio. Here these are the general features of population. Population density, birth rate, death rate, and sex ratio. In a population, occurrence of different aged individuals. In a population, occurrence of different aged individuals which are occur. That here the different aged individuals include pre-reproductive age individuals, reproductive aged individuals, and post-reproductive aged individuals. Here the individuals which are present in a population, the different age individuals which are present in a population, which are grouped into pre-reproductive aged individuals, reproductive aged individuals, and post-reproductive aged individuals. The age distribution is plotted. Age distribution is plotted in a population. Results. Age pyramids. The different the age individuals, the age distribution plotted in a population yields age pyramids. Here the age pyramids are classified into 3 different types of age pyramids. Some of the age, one kind of age pyramid, that is called as expanding age pyramid, stable age pyramid, and one more pyramid called decline age pyramid. There are 3 different types of age pyramids in a population: expanding, stabilized, stable, and declining. In the case of this expanding, it is the base of the pyramid. Above that base, occurrence of these are the individuals in a population. Particularly, at the region of a base, occurrence of one kind of aged individuals called pre-reproductive aged individuals. The second level shows reproductive aged individuals. The third one shows post-reproductive aged individuals. Pre-reproductive age individuals, and what is that? Post-reproductive aged individuals. Here in this pyramid, the post-reproductive age individuals are very less when compared to the other kind of individuals. Here the pre-reproductive age individuals are more when compared to other type of individuals in a population. That the pyramid, that is called as expanding pyramid. Particularly in this pyramid, stable pyramid, here the first level shows pre-reproductive age individuals. Second level shows reproductive age individuals. Third level shows post-reproductive age individuals. Here, this pyramid, the pre-reproductive age individuals and reproductive age individuals which are similar, same number. Therefore, it is called as a stabilized pyramid, particularly in the case of age pyramid. Here, the pre-reproductive age individuals and reproductive age individuals number is very same. And in the case of declining age pyramid, here it is the first level shows pre-reproductive age individuals. It is reproductive age individuals. It is post-reproductive age individuals. Here, the post-reproductive age individuals and pre-reproductive age individuals are same in number, but here the reproductive age individuals are more. Reproductive age individuals which are more in the case of one kind of age pyramid, it is called as decline age pyramid. The age distribution plotted in a population yields age pyramids. Here the age pyramids which are classified into expanding age pyramid, stabilized age pyramid, and declining age. These are the pyramids: expanding, stabilized, and declining age pyramids. Here the population size. The population size is always depends on population size. Population size is always depends on food availability. Predation pressure, and adverse weather conditions or adverse environmental conditions. Adverse weather conditions. These are the factors which influences the growth size. Population size is always depends on population size or population growth. Population growth is always depends on food availability, predation pressure, and adverse environmental or weather conditions. Population density, population growth or population density is fluctuated. Population density is fluctuated by four processes which fluctuates the population density. Here the population density, it means PD is always denoted as N. It is the population density is always depends on birth rate. Here the birth rate is also called natality. And population density is also depends on death rate. Death rate is also called mortality. Death rate, and it is also depends on population density. Is also depends on immigration. immigration and emigration. Here birth rate means the number of births in a population, that is called as birth rate at a given period of time. The number of deaths in a population at a given period of time, that is called as a death rate. Here birth rate is more, death rate is very less. During such time, population density increases. Suppose death rate is increases, birth rate is decreases. During such time, population density decreases. And also the other factors, other processes includes immigration and emigration. Here immigration means the number of individuals of a same species, come into the habitat. The number of individuals of a same species come into the habitat elsewhere during period of time. That is called as immigration. Here the immigration means the number of individuals of a same species come into the habitat from elsewhere at a given period of time. That is called as immigration. And one more term, that is called as emigration. Here the emigration means number of individuals of a population. The number of individuals of a population who left the habitat, gone elsewhere. That is called as immigration. Immigration means entry of individuals into the population. Emigration means the individuals out from the habitat. That is called as emigration. Here the four processes which fluctuate population density. Therefore, population density equation is always population density equation. Here the population density equation in which NT plus 1 is always equal to NT plus B plus E minus B plus I minus B plus E. Here NT plus 1 population density at unit time. Population density at a given unit time is always equal to population density at time plus birth rate plus immigration minus D death rate plus E means immigration. It is the one that is called as population density equation. Here the population density equation NT plus 1 equals NT plus B plus I minus B plus E. Here the four factors, four processes which fluctuate population density. The four factors: birth rate, death rate, immigration and emigration. Next to this that is called growth models. Here the growth depends on the four factors. One is birth rate, death rate, immigration and emigration. These are the factors which fluctuates the population population density or population size or population growth. In the case of growth models, there are two different types of growth models. One kind of growth model, that is called as exponential growth model, and logistic growth model. There are two different types of growths: logistic growth and exponential growth. Here the exponential growth, in this growth, in which the natural resources which are unlimited, in a geographical region, the growth rate is exponential. Here, in the case of exponential growth model, in the equation that is dn by dt, the population density at a given time is always depends on birth rate and death rate into n. Population density is always depends on birth rate and death rate. Birth rate and death rates, which are always depends on intrinsic factor. Here, the intrinsic factor is R. What is that? Birth rate and death rate, which are always depends on intrinsic factor, that is R. Therefore, dn by dt equals R into n. dn by dt equals Rn. It is also represented in the form of nt equals n naught e to the power of rd. N naught e to the power of rd. Here b means birth rate, d death rate, n population density, smaller intrinsic factor. Here nt population, it means population density at a given time, that is n0, n naught means population density at 0 time. R is the intrinsic factor, T is the time, E means negative logarithm of, it means base of the logarithm. Base of the logarithm, that is E. R intrinsic factor, N0 population density at 0 time. Here the R is the intrinsic factor, N is the population density. Here, in the case of this model, the population density against the time, here the population density is always depends on intrinsic factor, that is K, carrying capacity. Intrinsic factor, it means natural resources. If the natural resources which are maximum, therefore one of the curve is obtained, that is J-shaped curve is produced on a graph sheet. Here it is dn by dt equals Rn. It is a curve, that is the J-shaped curve is obtained in the case of exponential growth model, because the natural resources which are unlimited, then it's a one of the curve that is always J-shaped curve. It is about that exponential growth model. The exponential growth model is always depends on intrinsic factor. Next one, logistic growth model. Here the logistic growth model is the realistic growth model. It is very common growth in the case of a population. That is, here one of produced in this model, that is called as S-shaped curve or sigmoid curve is obtained in the case of realistic growth model, that is called as logistic growth model. Here, the equation of this model, that is dn by dt equals r into n into k minus n by k minus n by k. Here k means it is called as carrying capacity. K is the carrying capacity. Here carrying capacity means every ecosystem or environment or habitat has limited resources to support a particular maximum number of individuals. That is called carrying capacity. Here carrying capacity is denoted in terms of K. Here carrying capacity means every ecosystem has limited resources to support a particular maximum number of individuals. That is called as carrying capacity. Here the carrying capacity is always in the case of logistic growth model. In the case of this growth model, one of the curve is obtained. Here population density against the time. Here the horizontal line that should be shows carrying capacity. Here one of the curve is obtained in the case of logistic growth, that is S-shaped curve is produced. Here the S-shaped curve that should be shows the equation dn by dt equals Rn into k minus n by k. It is one of the realistic S-shaped curve. That S-shaped curve is always considered as sigmoid curve. Sigmoid curve is the common growth curve in the case of a population, that is called as logistic growth model. Here the equation of that exponential growth model dn by dt equals b minus d into n, or dn by dt equals rn. But in the case of logistic growth curve, dn by dt equals rn into k minus n by k. Here k means carrying capacity. Here carrying capacity means every ecosystem or every environment has limited resources to support a maximum number of individuals. That is called as carrying capacity. It is about that growth models in a population. See, it is the representation shows fluctuations of population density. Population density is always depends on here the natality, mortality, immigration. Population density is always depends on four processes. Therefore, the equation is nt plus 1 equals nt plus b plus I. B means birth rate, I means immigration, minus d death rate plus immigration, immigration. It is the population density equation. The growth models, which are two different types of growth models. One is exponential growth model and a logistic growth model. Equation of exponential growth model dn by dt equals Rn. That equation is called as exponential growth equation. The exponential growth produce a curve that is always J-shaped curve. J-shaped curve is produced. Here horizontal line indicates carrying capacity K. And one more model that is called as Logistic growth model. In the case of logistic growth model, the equation dn by dt equals Rn into K minus n by K minus n by K. It is the curve that is always S-shaped curve. That curve is called as logistic growth curve. Logistic growth curve.